for a sigma algebra. Okay, because for a sigma algebra generated by open sets. Okay, so open sets is included in for a sigma algebra. Okay. Complemental open sets is closed sets. Okay. Complement. If A is open, A complement is closed. So sigma algebra have this condition. If A is is included in sigma algebra, A complement is also belong to sigma algebra. Open sets, since open sets is included in Borel sets, closed sets is also belong to Borel sigma algebra. Okay. Can you explain this in Arabic? Do you understand it? Do you understand it?
Şest dersat. Şest dersat.
Kafasına düşmemiş.
Başa düşmemiş.
Başa düşmemiş diyor.
شنو include؟ يتضمن؟
Sigma algebra has two conditions, okay? One condition is A in Bx, then A complement is also belong to Bx. If A is open, then Bx A complement closed. Open sets are belong to Bx. So closed sets is also belongs to Bx. Do you understand? Okay. Explain it too.
البورد سيجما الجبر اللي هي جنريتد باي اوبن سيلز من المجموعات المفتوحه. البورد تتولد منين؟ من المجموعات المفتوحه. فالمجموعه المفتوحه اوبن سيلز is included in بورد سيجما الجبر. ايش راح تكون؟ اذا هذه اول التنميه مالتها شو تكون؟ مغلقه. مثلا A مجموعة A تنتمي إلى للBX. ال A complement أيضا belong to BX. ال A open. ال A complement
مغلقة.
Closed. If A is open, then
A complement
closed. A in Bx. So A complement is also in Bx. A open, A complement closed. So Borel sigma algebra contains closed sets.
Excuse me, Doctor. 1 inverse no. يعني A belong to BX closed no. Yes.
A
complement belong to BX, yes.
So A complement
is
متمم هي ترجع.
yes.
ولكن البي اكس
يعني العكس
هو العكس الرمز مالته
And that's rules of Borel. That's rules.
No, that's root of sigma algebra. Sigma algebra has two rules. One, two is
And Borel rules this.
This is the two sigma algebra has two conditions. Okay, one from condition two, from rule 2, we can conclude countable intersection of open sets and countable unions of closed sets are also belong to Bx. Okay, countable intersection of open sets.
تقاطع المجموعات المعدودة.
Countable
المجموعات
intersection.
المفتوحة.
Countable معدود.
معدود.
شمارة. Okay. معدود. Countable intersection of open sets and countable unions of closed sets are also belong to Bx. Okay. Can you prove it?
Yes.
Can you prove it?
For example.
Countable intersection of open sets. Okay.
تقاطع المجموعات المفتوحة.
Countable intersection of open sets. Okay.
واتحاد
We suppose AI is
Intersection of
And-
open sets.
and AI is belong to
Countable.
Bx. Okay. We must show that intersection of AI is also belong to Bx. Can you prove it? You cannot. We must use from two conditions.
Sigma algebra.
Two condition of sigma algebra and prove it. AI is open. Okay. So AI complement
Closed.
is closed. Okay. AI complement is also belong to
BX.
Yes.
Bx. Okay.
Yes.
From condition 1.
Yes. Two.
From condition 2, we have union. AI complement is also belong to
BX.
Bx. Okay. Condition 2. Condition 1. Also, again, use condition 1. This set is belong to Bx. So complement of this is also belong to Bx. Complement of union of AI complement of this set. Okay, is also belong to Bx. From condition 1. Okay, do you understand? De Morgan rules means, implies that this union is equal to intersection. AI complement is equal to Okay. We prove it. Intersection of AI is belong to Bx. Okay. Any question?
شباب هو مو اتحاد يجيكم من شو اسمه تقاطع.
ديمورغان.
هسه قوسين يكون
ديمورغان.
ياخذ الاي واحد يروح يكون مجموعتين والاتحاد يصير تقاطع بيكون هذا برهان مال التقاطع اللي هي النقطه الثانيه.
So intersection of open intersection of countable open sets is belong to Borel sigma algebra. Okay. Okay, we prove it. Countable intersection of open sets is belong to Yes. Countable unions of closed sets. Can you prove it? Can you prove it? Countable unions of closed sets
المعدودة المغلقة
is belong to Bx. Right?
نفس اخر الاتحاد ما عدا شو اللي خلاه نقطتين ثلاثه واحد منطقتين
Countable unions of closed sets. This is simple. This is simple.
نفس الطريقة. هو هذاك الحلول اصلا على دي واحد. اتحاد.
Closed sets, okay? Closed sets are belong to Bx, okay?
أي
Closed sets
أي
belong to Bx. Suppose AI
من بي
from
اكس
1 to infinity is
Bx.
closed, and AI in Bx. So from condition 2, we conclude union from 1 to infinity AI
Bx.
belong to
Bx.
Bx. Countable union of closed sets Borel is Borel. Okay. Any question?
For example,
Example.
simple example.
هو هذا example.
We need example.
We have some terminology. Standard terminology. اصطلاح استاندارد نامگذاری name. Okay. Countable intersection of open sets. Countable intersection of open sets is called G delta set. Countable G delta. G delta. Countable intersection of open set is called G delta set. Okay. And countable union of closed sets is called F sigma. F sigma. F sigma. Countable union of closed sets is called F sigma set. So F sigma set A is F sigma. This means A is countable union of closed sets. Okay. B is
Sigma.
G delta. Means B is intercountable intersectional open sets. Okay.
Okay.
Countable union of G delta set is called G delta sigma, and countable intersectional F sigma sets is called F sigma delta. Okay. Definition. These are definitions. Okay. And not need to prove definitions. Countable. تعريف. In Arabic تعريف. Countable intersectional open sets is Borel sets. So we call G delta sets is Borel sets. With G delta sets is Borel and F sigma set is Borel. Tarif. Okay. Example. Borel sets in R. B R. Borel sets in R real line. Borel sets in real line. In R, open set R in the form open interval. Okay, open sets are in the form open interval, or open interval R is open set. Okay, so here R is generated by open intervals. A. Here R is generated by each of the following. 1. A. The open intervals. The open intervals. EH is the set of all open intervals in R. Here R is generated by EH. Also, B. The closed intervals. This means here R sigma algebra, Borel sigma algebra on R is generated by EDO. EDO is the set of all closed intervals on R. Okay. The half open intervals. Half open. E3. E3. Open in A. Close in B. Okay. The set of all intervals such as this. A, B.
I not belong to.
A not belong to
A, B.
A.
Intervals.
E4 close in A, open B. BR is generated by E4, E3, E2, E1. Also, BR Borel sigma algebra on R is generated by open rays. A infinity. All intervals A and infinity or minus infinity A. Okay. And closed rays. So we are Borel sigma algebra on R generated by E1, E2, E3, E4, E5, 6, 7 and E8. Okay.
مجرد خصائص مجرد خصائص
هذه كلها مفتوحة ومن السالب على الموجب.
راح يثبت نسوي اثبات.
شلون تحفظ؟
يخطب بينا.
We not proved the proof of this theorem not me.
ما يريد الإثبات ما يريده.
وهم يمرون إثباته.
الاثبات ما مطلوب.
إثباته شنو؟
ما مطلوب.
على أساس راح نغلط النيش.
measure
قياس.
in Farsi اندازه.
عربي قياس.
اندازه.
أندازة. احنا عربي ما ندري.
اندازه.
Yes.
وزن. No.
قياس.
اندازه.
متر.
اندازه. measure means اندازه یا قیاس in Arabic. قیاس. measure is a function such as move. We do not measure by move. A function move from m to this interval. Okay. M is sigma algebra on X. Then is sigma algebra. Move from M to this interval. Okay. M is sigma algebra on X. X is a set. Okay. Measure has two conditions. One, mu phi is 0. Mu phi is 0. Okay. Two, if Ej from 1 to infinity is a sequence of disjoint. Disjoint means
غير متصل.
disjoint means مجزا جدا از هم. disjoint sets in M, then mu union of Ej is equal to sigma from 1 to infinity with Ej. Summation. Sigma.
مجموع.
In Farsi we call it sigma.
In Arabic,
مجموع.
In Farsi we call it sigma. Sigma from 1 to summation from 1 to infinity. But attention that this set
disjoint.
Ej is sets Ej
disjoint.
Ej disjoint. This means EJ and EI has no intersection. The intersection of
قاطعهم
EJ and EI
فاي
is 5. EJ intersection EI is 5 if I is not equal to J. Okay, measure is a function from M to this interval. Okay, M is a sigma algebra. So measure is defined on a sigma algebra. Measure, we can define a measure on a sigma algebra. So we can, if we have not a sigma algebra, we cannot define a measure. Measure is defined on a sigma algebra and has two conditions. Okay. Condition two, property two is called countable additivity. Countable additivity. Countable additivity.
Excuse me. EJ intersection
EI.
equal 5. I
Is not equal to J.
is not equal.
So EI and EJ becomes EI and J is disjoint.
J, for example, J equal 1, 2, 3, 4 to infinity.
E1, E2, E1,
Come on.
E3,
Come on, yes, yes, yes.
E10,
Yes,
E11,
yes.
J from 1 to infinity, I from 1 to infinity. But I and J is
نو كيو
يعني سوى العجز اللي سويتها هاي الجيش يطلع بعد التقاطع ساكن فاي.
لا يطلع نفس القيمة تقاطعها نفسها.
لما اسوي شيء يقول اي تساوي جي.
لا لازم شرط واي تساوي.
هو شيء يقول
لا هو لازم الاي والجي واي تساوي. اذا ساوي
الاي هاي الاي هو المجموعة الأصلية. مجموعة العناصر مالتها مو نفسها. طبعا هذا الشرط هو واضح لا يعني مو اي 1 يساوي اي 2. طبعا تقاطعها نفسه. اي 1 وهي اي 2 الانترسكشن مالها ايش قد؟ 5 ما تقاطع
يعني
مجموعة.
لازم جي ما يساوي.
طبعا يعني
اذا صار راح تطلع
إيه،
ما تطلع
تقاطع بينهم.
يعني اذا طلع تقاطع ما يحقق شرط مو؟
لا
إذا
قاطعهم بس
اذا قاطعتهم طلع تقاطع.
ليش استاذ؟
ما راح
شنو السبب؟ لانه السبب سيكونس اوف ديسجوينت.
إذا
يعني ماكو بيناتهم الجوينت شنو؟ رابط.
إذا
الجوينت ماكو رابط بيناتهم.
إذا تساوي أنت راح تقاطع المجموعة مع نفسها.
يقول الان ديسجوينت
بالضبط.
سيكونس
يعني شيء
ديسجوينت.
خلينا نقول شيء ما يشبه شيء.
تمام. E1 E2 E3 E4 انترسكشن مالهم شنو صار؟
ترى صعبة هن بين إذا تساوي راح تقاطع المجموعة مع نفسها.
all of our sets are disjoint. This means E1 intersection of E7 is 5. E1 intersection of E2, E1 intersection of E3, but all is equal to 5.
Because 2, if EJ 1 to infinity is a sequence of disjoint sets.
Disjoint sets is necessary.
Yes, يكون جدا مهم هاي انه disjoint لازم بيناتهم تقاطع هاي المجموعة.
Measure sigma algebranın üstünde tarif olur. 2 tane de şartı var. İki şartı var. Bu yer 5 sıfırdır, 0'dır. İkinci şartımız ki İC'ler disjoint olsa bu yer ettihadı İC'ler onlar summation bu yer İC'ler. Okay, iki şartı var. Measure'in iki şartı var. Buradan düze desek measure değil. Yeter iki şart.
İki tane şart var.
İki tane şartımız var.
قلنا ما تجي نعرف ايش عمي هو صاحبنا عمي هو
This condition, this property 2 is called property 2 is called countable additivity. Okay, from condition 2 we can conclude finite additivity. Okay, finite additivity. To prove finite additivity. Property to prove finite additivity. If E1, E2, En are disjoint sets in M, then union of Ej is equal to summation of Ej from 1 to N. 1 to infinity. 1 to infinity means countable additivity. 1 to N means finite additivity. Okay. From condition 2, we should prove condition 2 prove. Can you prove it?
What?
Can you prove it? From condition 2,
Yes.
conclude condition 2 prove.
باقي المعادلة اللي شفوها بنطلع بنهاية المعادلة من يقدر يفضل يولد؟
From condition 2, conclude to condition 2 prove.
باستخدام الكونديشن الثاني نطلع الفريق. منو بيكون يفضل يولد؟
Bundan gerektiğini netice var. Azim ile netice veriyor. Bundan bunu netice var.
Yani ondan vurulan
Bundan buna geliş. Burada 7'den tafinayete birden. Buradan birden de
Enedir bu.
enesin. Netice.
Ender burada mesela büyük bir şey var burada.
Ha?
Excuse me. Path T to condition 2 dash.
We prove condition to prove. We conclude condition to prove from condition 2.
Condition 2 sigma algebra.
No. Sigma algebra is no. M is sigma algebra. Mu is measure. Okay. M is sigma algebra. Mu is measure. We must show that condition 2 implies condition 2 prime. Can you show it? I show. Okay. In condition 2, we put En plus 1 En. It's fine. Okay. So, union from 1 to infinity, if I is equal to union from 1 to N. Okay. Because En plus 1 is 5, En plus 2 is 5, and so on. Okay, this is 5. This is, and all of the set is 5. A union phi is equal to A. So in E1 union E2 union E3 union En union phi is equal to
Yeah.
okay because En plus 1 is phi. A union phi is equal to A. E1 union E2 union En union phi is equal to this. Okay.
واضحة شباب؟ واضحة هاي.
الساعة كلام
واضحة لازم واضحة؟
لا والله
واضحة؟
لا
Yeah.
So we conclude union from from 1 to infinity I is equal to union from 1 to n ei because En plus 1, En plus 2 and so on is equal to 5. Okay? Okay. From condition 2, we have condition 2. We have moon union 1 to infinity Ei is equal to summation from 1 to infinity with Ei. Okay. We show that this union is equal to this. Okay. Union from 1 to n ei, but by this condition. Okay, by this assumption. Summation from 1 to infinity is equal to mu e1, mu e2, mu en. Okay. Mu en plus 1, mu en plus 2 and
To infinity.
to infinity.
To infinity.
En plus 1 is condition 1 from measure. Condition 1 from measure. Where phi is
Zero.
0. So this is 0, this is 0, and to infinity is 0. So this summation is mu e1, mu e2, mu en. So we can write this summation from 1 to en. Okay. So mu union from 1 to n I is equal to summation from 1 to n. This is condition to prove. Condition to prove. Mu from 1 to n, summation from 1 to n. We conclude condition to print from 2. Do you understand? Any question?
هو مجرد قانون طلع من ذاك القانون.
This is simple proof. Very simple proof. Very, very, very, very
Easy.
Huh?
Easy.
Easy.
Easy rumors.
ايزي لو ايزك.
Real analysis has very, very long proof
Yes.
and
Very hard. Very hard.
Very hard.
Yes.
This course is analytic, and you must read again.
We don't have some minutes, some time.
Some
We don't have some time.
because
The job of
job, money. Can you explain this again in Arabic? Do you understand it?
Yes.
Again, explain it in Arabic. Say ben Türkçe. Bak bir en klasmandan o zaman hamısını tuturup fay. Fay tutsam bunlar uzun olur. İttihadı fay. Olur değil mi?
Fay.
Bunların hamısı faydı. Bu da faydı. Bu da faydı. Bunun bu ittihadın faylarını bulacak.